All right, so let's start with the reference sheet. If y'all don't have the reference sheet on you, it's fine. Okay. The reference sheet, of course, is something that you will be given on the day of the test. You will not be able to use your copy. It'll have to be something that you're given, okay? So I want to talk just a bit about what you need from this reference sheet. This reference sheet is just the high school reference sheet. So it has all these conversions on the left side that I can guarantee you won't see, all right? All of our stuff that's important is over here on the right side. So you've got exponential growth and decay. That's when it's just real simple, okay? Something's going up by a certain percentage. That's what you put into R. Remember how we deal with that percentage? Let's say it's 3%. How do you write that? How do you write 3% as a decimal? Exactly. You move that decimal 2 to the left. And that's, of course, what will go into our position. So in all these places where you see R, you got to remember that's what you're going to do. You're going to move that decimal 2 to the left. Okay? That's how we deal with the R, the rate. Now, as far as the other stuff in this formula, it's all straightforward. A is your starting amount, and T, of course, is your time. So for growth, it's going up. For decay, it's going down. Now, the next thing is the compound interest, and I can guarantee you guys this is going to be on the test. Guarantee it. So you have this P value. P is your principal amount, right? That's the amount that you start with. We already talked about R, the rate, where you have to move that decimal 2 to the left. But can y'all remind me, what is N in compound interest? Do y'all remember that? What is N? N is the number of times it's compounded. Number of times it's compounded. You see, what it's going to say to you guys is it's going to say something like this. It's compounded quarterly. Or it's compounded monthly. It'll say something like that. So it's going to literally say compounded. So you know you're dealing with compound interest. But then it says something like compounded quarterly. Well, guys, what does quarterly mean? How many times is that compounded? If it says quarterly, 4 times, right? So quarterly would be 4. What if it says compounded monthly? 12, right? So those are your big ones, compounded quarterly and compounded monthly. There are some others, though. Semi-annually. What does that mean? Semi-annually. Nuh-uh. Semi-annually would mean twice. 2 times. Annually, of course, would just be once. Then you've got weekly. What would weekly be? Do y'all know how many weeks there are in a month or a year? 52. So weekly would be 52. But your big ones, listen, seriously, are quarterly, annually, and monthly. So that's what goes into N's position. And of course, y'all know T, right? T is time. Now, the next one, continually compounded interest. The key to this formula is it's got this E in it. So listen, I promise you, they will never give you a continually compounded interest formula on the non-calculator portion. So remind me, this will be on the calculator portion. Where do you find E? Look at your calculator, guys. Where do you find E? Both of them are second keys. You can either do second ln or second divided by. Y'all see it over there? Second divided by. Those are your two options for E. So I promise you, if they give you a continually compounded interest formula, they will literally say it's continually compounded, which keys me into this formula. And you only have to find, the big thing here is finding that E in your calculator, second ln or second divide. Okay, arithmetic sequence and geometric sequence. Please remember how I know when to use either arithmetic, and it's all about the variable D, or geometric sequence is all about the variable R. Now, is that R right there? Is that rate? Is that like 3%? No. R and D are the distinguishing characteristics that will tell me, hey, you need to use an arithmetic sequence, or hey, you need to use a geometric sequence. D is when you have a common difference. A common difference. And you find that value by doing a sub 2 minus a sub 1. Or they're going to just straight up tell you guys that it's adding, or it's going up by 3, or it's going down by 4. That's what they're talking about. Okay? It'll have a common difference. Okay? So like if your numbers are just going up 3 every time, just consistently going up 3 every time, well, that's a common difference. You know to use the arithmetic sequence. If your values are going down by 2 every time, well, your common difference is -2. You know to use an arithmetic sequence. But what about a geometric sequence, y'all? What keys me in on that? That's a common ratio, which we find by doing a sub 2 divided by a sub 1. Remember that? So this is being used when we're multiplying by the same thing over and over again. So it might say that it's getting 3 times bigger every time. See how it says 3 times? You're multiplying by. It's a common ratio, and therefore it's a geometric sequence. So please know what distinguishes an arithmetic sequence from a geometric sequence. You know what else you could do? Look at all the equations in your answers. If you can see all your answers, won't it kind of distinguish which type of equation it is? If it has a plus or a minus in it, it's arithmetic. Okay? If it has an exponent, it's geometric. Now, the finite geometric series was a formula that we didn't talk a lot about, and I told you we had an example of this in one of the practice tests. The key is you're going to have this type of problem in a situation where they give you the formulas, and the key for you is to remember what is my a sub 1 value, and making sure it's out front, and then the R, that your R is found correctly, and that R is the same R as above. That's your common ratio, a sub 2 divided by a sub 1. Okay? That's how we know when that's going to be. And the last two formulas that they give you on your reference sheet is if you want to change a degree to a radian or a radian to a degree. So it's very simple. Okay? Any questions with any of these formulas that will be given on your reference sheet? More than anything, guys, when you're reading a problem and it looks like there's some type of equation needed to solve it, look at your reference sheet. Don't forget your reference sheet is there to help you, okay? Now, the stuff that I would love for it to be on the reference sheet. The one thing that I would love absolutely for you guys to memorize, and then one thing that I would love for you guys to remember. Okay, here's the one thing I would love for you to memorize. The quadratic formula. The quadratic formula. Remember, you use the quadratic formula when you have a quadratic equation. Your x squared coefficient is a, your x coefficient is b, and your constant is what we call c. And I plug it directly into the equation. Philip, you with me? Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Philip, what are you doing? Okay, got it. So this is definitely something that I would encourage you guys to memorize, because there are definitely questions on the calculator and non-calculator portion where the quadratic formula could be useful, okay? How many of you guys think you can memorize that? That's the one thing I would love for you to memorize before tomorrow. This is the one thing that I would love for you to remember. Please don't forget that I squared equals -1. Okay? Don't forget that. I squared equals -1. All right? Now, where do you see this in a problem? Well, here's where you might see it. You remember where we did 4 plus 3i times 2 minus 6i? Huh? What did we do first? 4 times 2 is 8. 4 times -6i is -24i. Then I switch over. What's 3i times 2? So plus 6i. And then lastly, what's 3i times -6i? -18. And here's the key. I times I squared. Right? I times I squared. And what did we just say I squared equals? So that turns into a -1. And then I can say, hey, if that's -1, what's -18 times -1? So this turns into plus 18. So now all of a sudden, I have these like terms that I can get together. What is 8 plus 18? 8 plus 18. 26. And then lastly, what is -24i plus 6i? What's 6 minus 24? -18i. So when you multiply those i's, it turns into I squared, and I need to remember that I squared equals -1. Okay? Now, this is the icing on the cake formula. When it comes to the measure of parts of a circle, I told you guys about this problem or this little formula because we had one example in all of the practice examples that we went through. This is only one time did we see this. So this is probably not going to be a heavily tested thing, but we might run into it. And if you could remember that in a circle, okay, here's my circle. I can do a perfect circle. Watch this. Perfect circle. If I have a circle, okay, and look at this. If I were to draw right here, that right there is the arc length, right? That's the top. And it forms right here a central angle. Whoa, that was real bad. So this would be your central angle. This would be your arc length. If I want to try to find either of those, here's my formula. The arc length, this thing, over the whole circumference of the circle, the whole distance around, 2 pi r, is equal to the central angle, this thing, over either 360 if we're dealing in degrees, or 2 pi if we're dealing in radians. And your calculate or your question and your answers will key in which one of those you're using. Okay? This would be an awesome formula. So, please remember your reference sheet and the things that are on it. Please memorize quadratic formula and try to definitely remember I squared equals -1. Those things are key, okay? Key. And then this formula is icing on the cake. All right, now let's go to that paper I gave you, please. And we're going to jump through pretty quickly all of these different keys to your calculator. Ready? If it says finding zeros, roots, x-intercepts, and I'm going to add another one, or solutions. If it says any of those 4 things, zeros, roots, x-intercepts, or solutions, Remember how we can do this. First of all, we're going to go, if you see all these problems down here, we're going to go and type these into y equals. Okay? We're going to type into y equals. So whether it looks like this and it says find the roots, or it looks like this and it says find the zeros, or if it looks like this and it says find the x-intercepts, we do them all the same way. We're going to go to y equals, and then we're going to either look at the table, look at the graph, or we're going to use second, trace, we're going to go to number 2, which literally says 0, and we're going to hit enter on the left. We're going to hit enter on the right. Remember all this? And then we're going to hit enter one more time. And it's going to spit out that particular x-intercept, that particular 0, that particular root or solution. So here we go. Y'all ready? Let's go to our calculator. Go to y equals. I'm going to type it in. X squared minus 3x minus 4. I'm going to look at the graph, and can't you kind of see them? What's that look like it's doing? Looks like -1. What's this one look like? Not -4. +4, right? So I can look at the table, and sure enough, at -1, what do you see, Grace? Your y is, it's a 0. It's a root. It's a solution. It's an x-intercept. Also at 4, you have a y that's 0. Or we could do the other way. Second trace, number 2. We could go just to the left of that point right there, push enter. Just to the right of that point, push enter. Push enter one more time, and sure enough, what's that solution? -1. And then let's do it one more time. Second trace, number 2. We're going to go down to the other one. So just to the left of it is below it. Push enter. Just to the right is above it. Push enter. Push enter one more time, and sure enough, my 2 solutions, my 2 roots, my 2 x-intercepts, my 2, I don't know which one I haven't said, zeros are -1 and 4. That is the easy way to find solutions, guys, in your calculator. Look to see where it crosses the what? The x-axis. Look and see where it crosses the x-axis. Any questions with that? All right, log base. Let's go to the next one. Log base. Where do we type in log base? Anybody remember? Alpha, window, and which one is it, y'all? Number 5. Alpha window number 5. So whether it's like this problem where it asks us to find the x-intercept and it uses log base in it, or it just straight up asks me to find log base 2 of 1/4, I can do these. First, for this one, I'm going to go to y equals, and like y'all said, alpha, window, and sure enough, number 5. Log base 2 of x plus 1, and then outside of that, minus 2. And just like the last problem, I need to find where it crosses the what? So it looks to me like it's somewhere around 1, 2, 3, somewhere around 3 or 4. Y'all agree? So here I go. Second trace, number 2. I'm going to go just to the left of where it crosses the x-axis, push enter. Then I'm going to go just to the right of where it crosses the x-axis, push enter. Push enter one more time, and sure enough, where's it crossing the x-axis? At 3. Your x-intercept is 3. Or, if the question is just straight up asked, log base 2 of 1/4, we can go to the home screen and do alpha, window, number 5, for log base 2 of 1/4. And what do I get? So -2. So please don't forget where log base is located, okay? Can y'all remember that? All right, some easy stuff that sometimes people forget. What about fractions? Alpha y equals number 1. Okay? Alpha y equals number 1. How about absolute value? Where do we go for absolute value? Alpha window, and you're exactly right. Number 1 says ABS. Please don't forget what absolute value is. That's your bars, right? So something like that. You'll see. That's how you know to do absolute value. Can y'all remember those? Okay, here's a pretty cool one. If I want to solve an equation that has no answer choices, so look at this, guys. See how this is just an equation? Would y'all know where to start to try to solve this equation? You got the absolute value of x plus 2 minus 2 on one side equals x over x minus 2 on the other. Would y'all know where to start on that? Pretty tough, right? Well, here's what we can do. 1, we can go to y equals, we plug one side into y1 and one side into y2. So let me show you what I'm talking about. See the equal sign here, guys? I'm going to go to y equals. Let's clear out what's in there. And let's plug one side of that equal sign into y1. So let's do alpha window number 1, we just talked about. Let's do x plus 2. And then on the outside of that, minus 2. But then we go to the other side of equals, and we plug it on the other side. So we've got x over x minus 2. Not plus 2, guys. Minus 2. And then I graph it. So let me go back to our paper. So we've done that. Then next, we're going to look at the graph. And we're going to use second trace. But this time, we're going to use number 5, which says intersect. Intersect. We move close to it and hit enter 3 times. Okay, just boom, boom, boom. So let me show you what I'm talking about. So you see this graph? How many times do you see this graph here and this graph here? How many times do you see them cross? Y'all see one here? 1. Here's one here. 2. Here's one there. 3. They cross each other 3 times, right? So look, I want to find those 3 locations where they cross. So where do we say you go? Second trace. And number 5, intersect. Now go close to these points. So let me start over here on the left. And we're going to push enter 1, 2, 3 times. Now here's the key with this, guys. Go back over here with me. Were these 2 equations? No, this is one equation. Just 2 sides. If I were going to solve this, what would I be solving it for? I'd just be solving it for x, right? Here's the point. What am I looking at here? Am I looking at the whole ordered pair? No. I would just be solving for what? All I care about is x. What's this x value for this intersect? Negative 4.7. Let's find this one right here. Y'all probably know what it is, don't you? What's it look like? Let's see. Second trace, number 5. Let's get over here closer to it. And let's push enter 1, 2, 3 times. And sure enough, Grace, you were right. 0. And then let's go to this one too, right here. So second trace, number 5. Scroll up there. Get as close as we can to it. Push enter 1, 2, 3 times. And what's your last x value? 3. So guys, my answers for this equation was negative 4.7, 0, and 3. Does everybody understand this? Now we're gonna skip something. We'll come back to this in a minute, but I want to do this first because I want you to understand the difference between, look guys, the way this looks right here. No, I didn't mean to mark it out. I meant to highlight it. I want you to see the difference in the way this looks here, and go over on the back side and look at this part right here. Are y'all on the back? Y'all see the difference? Is this just an equation that I am solving for x? No, I have a y equals here, and it has its own equation. But then I have a y here, and it's in its own equation. So the first thing we need to do in a case like this is we need to solve for y. Now, do I need to solve for y on the top equation? Somebody say no. No. So let's solve for y on this one. So I would add y over here. So 3x will equal negative 1 plus y. What do I do to get y all the way alone? To get this y right here alone. I'm going to add 1. So if I add 1, guys, 3x plus 1 equals y, correct? So look at what I've got. I've got 2 separate equations where y equals something else. Here's the point. I'm going to solve this almost the same way that I just did the other one. I'm going to go to y equals. I'm going to plug one equation into y1. I'm going to plug the other equation into y2. I'm still going to do second trace intersect. Isn't this just like what I just did, y'all? Here's the difference. Watch. Ready? When I go over here and I go to y equals, I'm going to clear these out. I'm going to put one equation into y1. I'm going to put x squared plus x minus 7. I'm going to put the other equation into y2. 3x plus 1. I'm going to graph it. How many times do these things intersect? 1. And there's another one up here, 2. So I'm going to do second trace. I'm going to do number 5 intersect. I'm going to get as close to this one as I can and push enter 3 times, just like I just did. Here's the difference, guys. Am I just solving an equation? No, I'm solving a system of equations. So how's my answer different? When I'm just solving an equation like the problem we just did, all I cared about was what? X. But now I'm solving a system of equations. Do I only care about x? No, I care about the y too. I want the ordered pair. What is this ordered pair? -2, -5 then is that answer. And we got one more up here. Let's go find it. Second trace, number 5, intersect. Let's scroll up a little closer to that point. I know I'm going to run off the screen, but I'm going to get as close as I can to it, push enter, enter, enter. And what does it find that ordered pair to be? 413. So look, guys, this answer is -2, -5, and 413. Notice the difference. When it's a system of equations, when I have two separate equations, we're looking for the ordered pair. When it's one equation on both sides, I'm simply going to look for the x. So please understand the difference between those two. Y'all get it? All right, let's go back to the front then. Y'all ready to go back to the front? Okay, we got one more thing here to do. Equivalent expressions. Guys, when you see this word, equivalent expressions, what should that key in your brain? Huh? That they should have the same value, right? So what I hope pops in there is stored value. Stored value. So remind me, how do we do stored value? We do alpha. I'm sorry. No, I'm sorry. We take a number and then we STO for x. And sometimes we have to store it for another variable too. And we can do as many variables as we need to, can't we? So we're going to store it for x or other variables, whatever we need. Then here's the next thing I want you to write. Type original problem to get a goal value. Type the original problem in order to get a goal value. Okay, when you've written that, I'm going to show you what I'm talking about, and then we'll do step 3. So look at this original problem. How many variables do I have, guys? 2. I got two variables. So here we go. Let's go to our calculator, and let's store values. Now remember what I told you. If you're storing values for multiple variables, use different numbers. So tell me, what do you want to use for x? Okay, let's use 2 for x. So push the number and store it for x. Push enter. What do y'all want to use for y? Don't use 2. Let's use 3 for y. So 3, store, and we find y using alpha 1. Enter. So now we've stored what Grace said. Did it matter what we stored? No, I like to stay away from negatives and zeros. And then also, if I have multiple variables, I want to use different numbers. So here we go. Ready? Let's type in the first original problem and get what we call a goal value. X squared minus y squared up top. And in the bottom, x squared plus 2xy plus y squared. And I know this is a little tedious typing all this in, but it's easy work, isn't it? So what's my goal value for these two values of x and y? What's my goal value for these two values that Grace told me for x and y? -1/5. That's my goal value. So let's go back to our paper. Step 3. What's step 3 going to do, guys? Any choice that shares the same goal value is an equivalent expression. Any choice that shares that same goal value is an equivalent expression. So here we go, and I'm going to go fast, okay? But what am I looking for it to equal? All right, so let's see. Let's go with A. It's a fraction. We got -1 over 2xy. Does that equal -1/5? So mark out A. Let's go to B. Also a fraction. Let's do on the top x plus y times x minus y. And again, I know this is tedious, but is this hard work? No, you just got to be patient and try your best. On the bottom, we got x plus y times x plus y. I'm going to push equals. Does it equal the same goal value, -1/5? Then B is one of my choices. Let's try C. Alpha y equals number 1. We've got x minus y up top. I'm typing them in just like I see them on my paper. In the bottom, I've got x plus y. Does that equal my goal value of -1/5? So C is an answer. Let's try D. Alpha y equals number 1. Up top, I've got x plus y. On the bottom, I've got x minus y. Does that equal my same goal value of -1/5? So it's not D. So lastly, alpha y equals number 1. Up top, I've got x plus y. And again, I know this is tedious, but don't miss these. Stored value. So x plus y times x minus y on the top, and on the bottom, x plus y in parentheses squared. I type them in just like I see them. Does that have my same goal value of -1/5? So my answers that give me the same goal value is B, C, and E. Equivalent expressions, please remember stored value. You're going to put your number, and then you're going to store it for x or any other variable you need. Okay? Questions about that? Okay, let's go to the back side. If you run into a system of equations, look at this, guys. That's crazy, right? Well, that's one of the last things we did before we started reviewing. We solved systems of equations that had multiple variables. Now this one has how many variables? This one has how many variables? It has 3. So here's what we're going to do. Y'all ready? First of all, you're going to type in, we're going to get this thing called RREF. We're going to type in second. Hey, Ellis, grab one of these papers right on the corner of my podium there. Second, and I'm making this video right now, so if you want to go back and look at all these keys to the calculator, it'll be on Google Classroom here in just a minute, because I'm recording right now. You'll hear this conversation. So I'm going to do second, and then I'm going to do x to the -1. Y'all find that button. We're going to scroll over to math. And then we're going to scroll up to RREF. All right, so go with me. Y'all ready? Clear this out. Here we go. Second, x to the -1. Scroll over to math. And then up to RREF. Not REF, RREF. Push enter. Okay, so get that on your home screen. Okay, number 2. We're going to do alpha. Y'all typing this? Alpha, zoom. And because this is a 3-variable problem, we're going to do a 3 by 4. What if it were 2-variable? 2 by 3. Okay? You won't have less than 2 variables or more than 3 variables. So here we go. Let's go back to our calculator. With our REF still there, do alpha zoom, and let's change this to a 3-row, 4-column matrix. And that's what it has. Hopefully you all have on your home screen right now. Okay, our last thing, go back to your paper. The last thing we're going to do is enter our coefficients and constant. Okay? We're going to enter our coefficients and our constants. I'm just going to leave it open. I guess people are starting to finish their test. What's up, if you grab one of those papers at the podium, that's what we're going through. I'm actually making a video right now. All right, so look, here we go. Y'all ready? What is my x coefficient in that first problem? 1. What's my y coefficient? 1. What's my z coefficient? -1. And what's my constant? 6. Go to the second equation. What's x? 2. Y? 3. Z? 1. Constant? 9. Go to your third equation. X coefficient? Y? And z? All the way down to our constant, which is? Now look, we've got our REF of this system of equations. We push equals. Remember how if those ones are diagonal, that means that my blank value is 1. What's my value that's 1? X is 1. Y is 3. And Z is -2. There's my solutions. So no matter what they ask me about, those are my solutions to that system of equations. If y'all can remember that, I can guarantee you that's going to be a couple problems that you really don't even have to think hard on it to come up with the solutions to them. Okay? So there you have it. Again, what time we got here? Huh? 28. Oh, me, we're struggling. I thought I'd have more time. Okay, square root. Where do you find square roots? Second, x squared. Right? Second x squared. Where do you find cube roots? Math. Number 4. Math number 4. Which says cube root of, like that. To do a fourth or fifth root, you're going to go to math. But you're going to do number 5, which says x root. And you're just going to enter what root you need for 4. Okay, last thing, summation. Y'all remember where to find summation? Alpha, window, which one, y'all? Number 2, summation. Now this was supposed to be an x right here, because remember, whatever this variable is here has to match this variable here. The only key to a problem like this is when you type this in your calculator, it gives you original parentheses. Everything has to go in the original parentheses, okay? So there you have it. That's a bunch of calculator stuff. This last thing is the same thing we've done. You type it in, and you find where it crosses the x-axis. It's just like the first thing. All right, so guys, please come tomorrow prepared to do your absolute best, right? To try your hardest. And, of course, use your calculator when you can. You can do it, okay? I know you can.